Hello, everyone, and thank you for joining today's webinar, The Future of Refrigerants, Balancing Sustainability, Performance, and Cost. Just a few technical details before we start our webinar today. If you would like to submit a question during the presentation, please enter it into the questions section of the GoToWebinar panel on the right-hand side of your screen. Questions will be answered at the end of the presentation. And now I would like to turn the webinar over to our host, Omar Mitchell, Vice President of Sustainable Infrastructure and Growth at the NHL. Omar?
Thank you very much. Good afternoon, everyone. Thank you for joining our webinar. It's my pleasure to welcome everyone today to the first of our NHL Green webinars that address some of the issues facing our industry. And it's really nice to see folks from around the U.S. and Canada joining us this afternoon or this morning for this webinar. So again, my name is Omar Mitchell, and my focus at the League is on community rink infrastructure, addressing barriers to entry to our sport. The League is committed to the places and spaces where our sport is played, and we want to ensure that we address some really significant issues, challenges, and the needs facing the indoor ice arena industry today. Our NHL Green Initiative, which we started in 2010, was designed with just that in mind, right? You know, we wanted to share these technologies, these best practices, these solutions that will ultimately help ice arena operators ensure that they are reducing their energy, that they are reducing their resource consumption, and that they're ultimately saving money, right? And, oh, by the way, they'll be going green. And so it's in that context that I'm really excited to start up these webinars to really share this information across the industry. And to that point, I'm very pleased to introduce Chemours. Chemours is the official refrigerant solution of the NHL. And we've invited them today to discuss the refrigerant landscape and the needs facing the industry ahead of the 2020 R22 refrigerant phase-out that's happening. It's important that we educate the marketplace and the industry on some of these challenges, and we think that this is something that is a very critical and important issue to discuss. So, with that, I want to pass it off to Chuck Allgood, who is the refrigerant technology leader at Chemours, to provide more info. And just to reiterate, we will be taking questions at the end of the webinar, so please stay tuned for that. And Chuck, off to you.
Thank you very much, Omar, and let me add my thanks for everyone taking time out of their busy schedules to join us today to talk about refrigerants, refrigeration systems, and things that are going on in the ice rink industry. In terms of agenda, what I want to cover today, talk a little bit about the partnership between the NHL and Chemours, why we're doing this, and then really get into the things that are impacting you all today, whether you're a mechanical who services ice plant chillers, or owner-operators of rinks, or you're somewhere in the refrigeration value chain. There's impacts, there's changes going on in the industry. Kind of cover those and then talk a little bit about the refrigerants themselves. Obviously, the working fluids have a number of different influences impacting historically things that have been used, what we're using today, and what we're going to be using in the future to make ice. Again, you'll see this theme of balance, balancing act, choosing the optimal solution, getting the optimal balance throughout the discussion today. But then I move into some of the new technology, particularly the HFO Opteon technology, hydrofluoroolefins, a new generation of refrigerants. End up with a case study, and again, as Omar pointed out, please submit any questions you have along the way. We'll do our best to answer all those, hopefully today. If not, well, we can follow up afterwards and get you the answers you need, because a lot of you are really in individual situations. So to start off, a little bit about who Chemours is. If you weren't aware, Chemours, we used to be part of the DuPont company, so we were the inventors of Freon. Freon obviously is a brand. It's not a specific product, although sometimes it's used that way. but have been in the refrigeration industry for over 85 years, making good, sustainable refrigerant products, high-performing, and are very committed to continuing to do that as we face the challenges of this century and going into the next 100 years of hockey in North America. The partnership that we put together with the NHL, we really earlier this year agreed, and really, as Omar pointed out, was to help the community rinks, the infrastructure, come up with cost-effective, sustainable refrigerant solutions so that those rinks can keep operating and keep developing the next generation of hockey fans, hockey players. So it's important that that whole youth hockey system that many of you are involved in be strong and sustainable, not only from an economic sustainability, but also an environmentally and safety sustainability perspective. So really what we're about here is focusing on the 4,800 or so community rinks, publicly owned, privately owned throughout North America, helping owners, operators understand, their equipment, the refrigerants they're running on, what choices they have, what things trade-offs they have to make going forward, all with the goal of keeping those rinks sustainable and operational. So if you're in the rink business, either as a service provider or an owner-operator or other, a lot of these headlines, and these are real headlines out of the news in the past, months and years, a lot of these issues you're facing on a daily basis, right in the center there. Energy, electrical costs are something that every rink is dealing with. In addition to changes in impacts, we talked a little bit already about the phase out of R22 or Freon 22 looming out just about a year from now. That will no longer be able to be produced in the U.S. Or Canada. There's also other issues. There's sustainability issues. There's infrastructure of equipment, aging equipment. Safety incidents have impacted the rink industry. Particularly disturbing to me on a personal level is that one in the upper right of a rink having to close down because the equipment was old. It developed a leak, which was a safety issue, and they couldn't keep operating. That's the last thing we really want to see, and that's one of the reasons why we put this whole program together. And again, even the Olympics, you may have caught the news from the Olympics a few years ago. They were getting some heat for not being particularly sustainable or having low GWP refrigerants in some of those facilities. So a lot of different pressure, and we're going to talk about all these issues as they impact your rink operation. So I always like to start off with, before talking about the future, kind of where we've come from. And this is a timeline of refrigerant technologies over the past 100+ years. So if we go back, more than a century ago, refrigeration was mainly an industrial process. It was done in industrial sites and used some industrial chemicals as the refrigerants, some things that were not particularly nice, you didn't really want to be exposed to, sulfur dioxide, methyl chloride, ammonia. And then really it was in the mid-30s, the early 30s, with the invention of Freon, the CFC family of refrigerants really became the golden age of refrigeration, particularly in Canada and U.S. And Europe. But really, when refrigerants and air conditioning and refrigeration was becoming out of the industrial process space and into our homes, our schools, our buildings, offices, supermarkets, and it really was the non-toxic, non-flammable nature of the freons, the first CFCs, that allowed that to happen in a safe way. Prior to that, there were some of these industrial gases were being used in domestic applications, and there were some incidents, and it was a real problem. So it really was viewed as a miracle compound when Freon was first invented. And the applications just grew, and the industry grew up until about the mid to late 1980s when the stratospheric ozone depletion issue was first uncovered. And then the industry was forced to look for new alternatives to get away from the chlorine-containing compounds. It's the chlorine in the CFCs, or the chlorofluorocarbons, which was the ozone depletion issue. And now, more recently, with global warming or climate change or carbon footprint, however you want to describe it, we're going through another transition to move to lower climate impact or lower GWP products, which comes along with our transition to HFOs or hydrofluoroolefin technology. A lot of the good same properties that the previous generation has, but now in addition to everything else, adding the property of low GWP to the equation. So that's kind of been starting that transition the last few years, and we'll talk more about that later. Again, I mentioned balancing and achieving the optimal balance of properties. So we've kind of split this into 4 different influences, and we'll hit on all these one by one. But there's regulatory pressures, there's always cost pressures, energy efficiency is a big thing for operations, and even health and safety when you get into the chemistry and the fluids that are going into your systems. So let's step through these one by one. And first we'll talk about regulations. And the regulations that are really impacting refrigerant choices or refrigerant options are based on the environmental impact. So just to be clear and to ground everybody, there's 2 environmental issues going on. There's ozone depletion, which is related to chlorine-containing refrigerants, so the CFCs, the HCFCs, things like R22, which basically is destruction of the ozone by reaction in the stratosphere. A separate but related issue is global warming, and this is the greenhouse effect. So any gases that build up in the atmosphere can potentially create a possibility of increased warming of the atmosphere. And the concern is if particular compounds have high global warming potential or are very potent greenhouse gases, they cannot be left to build up unchecked. So there's regulations coming down on both of those. So without getting into all the details, we could spend several hours just on the details of all the regulations because they're at the international level, like the Montreal Protocol and its Kigali Amendment, which was recently ratified. At the national level, Canada, U.S., even the state level, California and several other states are all jumping on the bandwagon to try and regulate refrigerants. Let me just simplify, and the bottom line is the regulations are in place to phase out of R22, and that's happening very shortly. The next chart will show the timeline. And there's also going to be a pressure to phase down on high GWP refrigerants, things like R507, which has a very high global warming potential compared to other options. So the details and the timelines may vary depending on the jurisdiction you're in, but the take-home message, again, R22 phasing out, and certainly there's going to be pressure on other high GWP refrigerants. For all of those who answered that R22 is a refrigerant, this is something hopefully you're aware of already. If not, you should really take this to heart here. At the end of 2019, a little over a year from now, we will be at 0 production of R22 allowed. So that's import and or manufacture. So we're in the final years of the phase out. After that, you can still use R22. It will be under the supply and demand dynamics that cover any refrigerant or any product in the marketplace as it gets scarcer and scarcer. And if you've had to buy 22 recently, you've probably seen some of that price volatility. We'll be on total reclaimed supplies to service everything going forward, and 22 is a very widely used refrigerant. So this deadline is coming soon, so you really need to pay attention to that. Switching over to one of these other pieces of the puzzle we're trying to balance, talking about energy efficiency. And it's really energy efficiency of the ice plant or the chiller system, which depends on a number of things, how it's designed, how it operates, as well as the refrigerant or fluid that's in it. Suffice to say that everything we do should be driven to increasing energy efficiency because there's obvious benefits to doing that. One is pretty obvious, is your electric bill. Everybody's paying that every month. So the more efficient, the higher COP or the higher EER you can get for your system, it's going to reduce your, keep your electric bills in check. There's also an environmental or sustainability component to energy. That is, any energy you use, any electricity, has a carbon intensity to it. That is, there's carbon emissions associated with generating that power, whether you're burning coal or you're on hydro or something a little cleaner. There is some carbon emissions to that. So increasing energy efficiency, again, reduces your electric bill, but also reduces your carbon footprint. So we always want to strive for good energy efficiency on any system or refrigerant choice. One of the other squares is health and safety and balancing that. And we like to point out that there's a couple different populations that are of concern, specifically when you get to ice rinks for safety. There's your workers who are working on the equipment around it kind of on a daily basis, over a working lifetime. Those workers need to be protected from any toxicity issues or flammability issues associated with a refrigerant. But there's also the population of what we call occupants. So this could be, kids skating, grandmothers in the stands watching a hockey game, people in attendance around the rink. And that's a different population from a health profile. Those people may not be as healthy as somebody who's going to work every day, like a worker. So there's different attributes of refrigerants you want to focus on. And in the white paper, there goes into a lot more detail, but looking at both kind of short-term emergency response kind of metrics around refrigerants, which here on this chart is listed as the acute toxicity exposure limit. So lower is more risky here, higher is better. That's the level you can get to without really running into a problem. But you also have the long-term or worker occupational type exposure limits. Those are usually caught up in the ASHRAE classification, so A or B, A being lower toxicity, B being higher toxicity. And again, the flammabilities, there's 1, 2, 2L, and 3 for refrigerants. For the most part, everything we deal with in the rink industry is non-flammable with the exception of ammonia. And ammonia usually gets most of its discussion around the tox side, but we shouldn't forget that it is mildly flammable or lower flammability and needs to be mitigated with the appropriate machine rooms, leak detectors, that kind of stuff. So let's go on to the final part of this balancing act. Again, is cost or economics. It always comes down to cost in some manner. And a lot of times when people are especially considering buying an ice plant or buying a new chiller, it's the capital expenditure, the CapEx. It's really, people get the sticker shock. That's the big ticket item up front. But if you really look at it over the time that it's installed and running, over its usable lifetime of 20, 25, 30 years, the energy costs associated with that chiller are at least as big as the capital, if not more. So we really need to make sure we balance energy efficiency with capital costs. And then there's also maintenance costs, and that could cover a wide variety of things. Service gas for refrigerant that leaks, training, preventive maintenance. There's some systems that typically break down and tear apart compressors, on a preventive maintenance schedule every 2 years, and just rebuild them as you go. Other systems are designed where they run, and you wait till something finally breaks, and then you just replace it. So a couple different ways of how the financials work out, but again, we're strong advocates at taking the big picture view and looking at the total cost of ownership that you're going to be facing when it comes down to selecting a refrigerant system or refrigerant fluid. So again, back to our theme and how Opteon, how our new technology platform kind of strikes this balance. We really are designing these refrigerants to hit that sweet spot in the middle and deliver good performance, capacity. It's got to do the cooling, it's got to do the chilling that it's supposed to do, but we want to do it in a very energy efficient way, but not trade off and get too expensive or too costly, either from an energy or a maintenance thing. If we have to do a lot of safety mitigation, that could impact cost. And again, all these are interrelated, and we want them to be nice and sustainable too. So, getting out of ozone depletion chemistry is going to be important, and getting to low GWP numbers to meet the regulations and those guidelines is important as well. All right, so now getting into the R22 situation. Since a lot of you have R22, and we can do this for you on a one-on-one basis, but we'll put together kind of a decision tree here to help you walk through it. If you have an R22 chiller, really what do you need to do? What are your options? And again, a lot of it is going to depend on the age of that equipment, or maybe if you answer this first question on this decision tree, when we say serviceable, that is, does this thing have useful life? Are you going to continue to operate and run it, for years to come? And if the answer is no, the thing is on its last legs and you have plans to replace it, then you can go down a pathway of selecting a new system with a new refrigerant. And there are a couple of good options I'll talk about later for new equipment in the Opteon HFO family. There's also other gases out there that could go into a brand new chiller. So in one sense, your work's a little easier if you know you're going to get a new system once you figure out how to pay for it. If the system is serviceable and you want to keep it running and it has R22 in it, you can keep it running R22, but remember R22 is being phased out. That's a little bit of a risky position from a availability and cost perspective if you'd have some kind of catastrophic leak and have to write a check to recharge it with R22. But there are options depending on the type of equipment, the design, to put other gases into an R22 system and keep it running. And if it's what we call a direct expansion or DX evaporator, that is a pretty straightforward process, and we've done a lot of that in a lot of commercial refrigeration systems, not all necessarily ice rinks, but cold storage, supermarket, warehouse type things, in addition to ice rinks. And we offer guidelines and have a lot of data to kind of support that pathway, if that makes sense. If it's in a flooded evaporator design, it's a little more complicated. But there is an option that some have done recently where you actually reconfigure part of the equipment, so it's not just a gas conversion, but it's not getting a whole new system, and reconfigure that evaporator to basically convert from a flooded to a DX, and then you can use something like Opteon XP40 or 49A, which again, very sustainable, energy efficient refrigerant. So depending on your system, and this is where our engineers would love to talk to you and help you kind of make these decisions or figure out what's the best solution for your situation. I would point out, because it's mentioned here, that R22 that you have in your installed system does have value in it. You can take it out if you have more than one chiller, and you can reclaim 22 out of one chiller and use it to service another chiller, or you can turn it back, cash it out. There are people who will pay you for that R22 so you can get that value back and use it to offset some of the costs moving forward. So the option to convert an existing system that was R22 in DX, so this is kind of the easiest of the gas conversion ones, is to change that over, as I mentioned, to XP40 449A. And we have a lot of experience in doing that. And we have published on our website guidelines for doing that. It involves a lubricant change. You have to go from mineral oil to a synthetic polyester lubricant, change some critical elastomeric seals that aren't compatible with the new refrigerant after being exposed to R22. But it really does match the thermodynamic performance of R22 very well in terms of enough capacity and good energy performance. And again, it kind of checks all the boxes on terms of sustainability. It has to be non-flammable because R22 is non-flammable. We have to stay in the same safety classification with a new gas. Again, it is a big step down in global warming potential, about 23% versus R22. You're also going from ozone depleter to a non-ozone depleter. So this has been a real popular decision, a popular pathway in commercial refrigeration, industrial refrigeration. Now, as I said, if your system is a flooded system, you're probably going to want to do some modifications if you're just going to want to do a gas situation, a gas exchange, where you're just converting the gas. And again, I'm going to get into a little bit on this Mars arena up in Duluth, Minnesota, that did a really outstanding job of doing this type of conversion, a year or two ago. And some of the details I'll get into, but it enabled them to put in a really good refrigerant that matched the R22. Again, it hit all the sustainability performance characteristics. It's been working well, and they actually won the Minnesota Ice Rink Managers Association award for this project. And I'll share some of the details here in the coming charts. So I think, let's move into that. So a little background on the arena. As I mentioned, it's in Duluth, Minnesota. The contractor, and let me give a shout out to St. Cloud Refrigeration and Justin Zembo, the lead contractor up there, who really did this work, planned it out, and really got the project done and exceeded all expectations. But that rink is a very busy rink. It does a lot of hockey, also figure skating, local skating. So it's very busy. It's in that age where we saw a lot of the rinks are. It's privately owned and operated, but a little less than 20 years old. So they were looking. They knew they had some exposure with all that R22 in that system, and wanted to kind of get away from that risk. So they started out looking at all their options, including tearing out everything and putting in a brand new system. But, based on the good work that St. Cloud did, putting this on paper and scanning out what it would take, how it would perform, what the cost would be, this looked like a really good option. So they went down and executed it here. And I think on the next chart we have, this is the details of it. So essentially they took off the flooded evaporator and put on a DX chiller barrel. So that was the main thing they did. The changing the elastomeric seals, changing the oil you would do with any conversion. They also upgraded the sensors. It had an electronic expansion valve put in it now, which gave better control, and that all contributes to better energy efficiency. The leak detector in the room just had to be upgraded, or it basically was a software update for the new refrigerant. But that's essentially what it took. And you can see the properties. I won't go through all of them there, or the comparison. But again, XP40, a really good replacement for R22 in terms of matching performance characteristics. So the results, the whole project took less than a week. I think they had budgeted a week to 10 days. Actually got done a little sooner than that. It started up right away without any problems. Pulled down, made great ice. Continues to operate now. We'll be going on 2 years here after the first of the year. But a couple of the benefits from doing this, aside from getting out of R22, was that the new design evaporator uses a lot less refrigerant. You got less than 50% of the charge that you had in there before. So that's a cost savings right off the bat. It's also an environmental advantage. If you've had some type of catastrophic leak, you just have a lot less refrigerant there that's going to leak out, besides being a lower global warming potential refrigerant. And the energy performance has been really good on this. And, a lot of things contribute to energy performance. It's not just the refrigerant, the better controls, the operating discipline, all that. But just as a snapshot, the 6 months following the conversion to Opteon versus the same 6-month period the year before, it's all about a 16% lower energy usage. So obviously, there's no guarantees these numbers are going to see it in every case, and your mileage might vary, but it certainly was an impressive decrease in energy usage in this particular case. And again, the operators and the rink owners were very pleased. So let me just shift here. That was kind of what you can do with an existing R22 system. You have a couple of different options. For new systems, as I mentioned, there's a few more choices. You have some of the industrial gases are still available, carbon dioxide, ammonia. But you also have, I would say, 2 flavors of Opteon that people are putting into new ice rink chillers. One being the XP40, which is the good match for R22. It's also a good match for 507 if you want to get out of the high GWP gases. And again, I won't go through all the benefits and values, but you see most of them entered there. And that will probably be your lowest, I would say, overall total cost of ownership, because of the good capacity of that, the equipment sizing and all is a really good match for R22-like systems. So if you had a 22 system, the Opteon is going to be a very similar in terms of cost and design and space it takes up. Operators and technicians are very familiar with how these systems operate, so you're not going to get into a lot of need for additional training or safety mitigation, those type of issues. There is another option for new equipment, and it's not really a retrofit option for most systems, but it can give you the lowest GWP fluid for these type of systems, and that's XP10 or 513A. If you're really into refrigerants, you'll notice the 500 series on the ASHRAE designation means it's an azeotrope, so it can be used directly in flooded systems. Has a little lower capacity. It's more like a 134A type refrigerant, so the system might be a little bigger. You might have a little more costs in terms of steel and copper in the system itself. But again, it can get you to the lowest GWP and still stay, A1 class, non-flammable, and operate very efficiently. And these systems are commercially available, I'll point out. You can order a system designed around 513A, and I'm sure some of you on the line either have one or have designed or built these type of systems. So that's some of the work going on. I will just say that Chemours, in partnership with the NHL, is here to support all this work and helping all of you out in your individual cases. So we have a lot of dedicated, really good, experienced technical people, engineers, located in Canada and throughout the U.S. to provide you that consulting decision-making process walkthrough. And in terms of all the associated technical documentation, engineering, technical data, MSDSs, case histories, retrofit guidelines, product information, any of that stuff that you need is available on our website. And we also share this through social media. If you're into Twitter, that's our Refrigerants Twitter handle there. But again, anything I think you need, if you're a designer, an engineer, a technician, certainly reach out to us. So, as I've said, we've been in the refrigerants business for going on 90 years. So this is kind of right in our wheelhouse, and we're glad to provide all this to you to help you through this transition. Winding up here, really, what would I advise you to do next? One, I would say, is to download our white paper, The Smart Refrigerant Selection for Ice Rinks. It goes into a lot of the information I covered here. A lot of these infographics are in that white paper. It comes in two parts. Make sure you get both parts. But it hits on regulations, energy efficiency, cost, safety, handling. It has questions to ask yourself to help you work through some of these decisions. And that's available at optforbetter.com/NHL, free of charge. And as follow-up to this webinar, you'll probably be getting some follow-up email, asking what you thought about the webinar and for further information. So certainly you can reach out to us. I put my personal email on here. Certainly anyone can email me, and I'll respond directly or connect you with one of our engineers in your territory to answer your questions. Because there are a lot of moving pieces here, and there are a lot of questions. So let me just wrap up. This is a quote right out of the NHL Sustainability Report. And really, hockey, we all have a role into making hockey available for the next 100 years. And it starts with that community rink infrastructure that Omar talked about. Whether we're operators, owners, service providers, or vendors, or our players, or some combination of that, I think we all have a role in doing that. And it's not just hockey. It's recreational. It's figure skating. It's curling. As anybody who needs a nice ice pad needs to figure out how we're going to keep that going from a mechanical, economic, and environmental sustainability perspective. So I know I've been talking a lot. Hopefully I think we've gotten some questions in, but I think I'll push it back to Omar at this point. And Omar, if you want to run through some questions, I think we have time to answer some of them, and we'll go from there. But thank you, everybody, and certainly reach out to me. Be glad to help you.
Chuck,
Omar.
Thank you so much. Thank you for sharing that info, and a lot of good, valuable info, and I hope it was useful for folks. And just to reiterate the last point on the slide, we do care. The NHL wants to make sure that the sport of hockey thrives for future generations, right? We just celebrated our 100th anniversary. We want to make sure that that continues. So this type of information sharing is critical for our industry. We recognize that there are going to be many different options in the marketplace for refrigerants. There's no doubt about that. There isn't one solution that fits all. But what we believe is that when you think about the full balance of performance and safety and environmental and cost issues, we think that Opteon really does provide an optimal solution. So that's why it's important for folks to know about Opteon and HFOs, and for you to do your research, to reach out to the folks, your mechanicals, or to Chuck and his team. And so from that perspective, the first question we had was the contact info. How do we reach out to get more info? Chuck, I know you gave your email address. Anything else?
Yeah, my email address, if you have that, it's charles.c.allgood, ALLGOOD-1 at Chemours. That's my personal email. I will certainly respond to that. Also at optforbetter.com/NHL, where you can go to download the Mars Arena case history. You can download the white paper. I believe there's also a contact us form there, so you can type in a question and that will get to us as well, and we'll make sure somebody gets back to you that way. So I'd suggest either or, whatever works for you there, an email or going to the website.
Awesome. Okay, thanks for all the folks who did submit their questions, and they're coming in hot and heavy, so I just want to make sure that we're covering them all. The first question is, are there manufacturers out there today that can supply chillers with Opteon and HFOs?
Yes, there certainly are, and they have been doing that for some time. So, and in different sizes, from bigger ones to smaller curling rinks. I'm a little hesitant to name any names here because I haven't cleared it with anybody, but I think without too much trouble, if you go to some of the standard names you hear of in this industry and in the refrigerant industry in general, they are all building and selling, installing, and operating systems with Opteon. So this may be new to some of you who aren't in the refrigerant game on a daily or weekly basis, but yeah, we've been working at this for nearly a decade now, starting out in the automotive air conditioning industry and then moving into refrigeration, cold storage, industrial chilling, ice rink type stuff. Okay,
got it. This is one. What is the best choice for a new ice rink chiller today?
Well, it's a balance, and it's going to depend on an individual situation. But there are, I think you want to obviously get something that's going to be sustainable and get you well under the regulations going forward, that you can expect over the next 25, 30 years. That's, if you consider that the life of your chiller. And then after that, it's a balance of balancing, upfront capital versus safety and health versus environmental properties versus energy efficiency. I would, particularly in the Opteon space, I think there's two choices. There's the XP40, which looks a lot like R22, except it's low GWP. And then there's the XP10, which is the lowest GWP solution and has a little different trade-offs on some of the other ones. So I think, everyone has to kind of look at what their values are, what's important to them, their financial situation, their, how they want to go green, that type of thing. But as you mentioned, there is no one solution, but under the Opteon umbrella, you have a couple different good solutions.
Okay, got it. This one was for me. Thank you for submitting that. Will the NHL be doing any other webinars on other sustainability topics? Absolutely. That was the genesis of our Greener Rinks Initiative, which was to provide information on the to the industry on energy efficient and environmentally sustainable technologies, products, and services. And one of the things that I ask of you, anybody, to reach out to me at the NHL to let me know about the topics or questions that you have that you want to address, and then we can line up the right folks to bring that information to you all. And again, this is all part of the league's focus on this industry and on providing the best information on technologies, products, and services that will ultimately save you green and go green. Zinger. Okay, Chuck, just a couple more last questions here as they roll in. What is the difference between, yeah, that's a good one. Just a basic question. What's the difference between a phase out and a phase down?
The difference between a phase out and a phase down?
Yes.
Yeah, in terms of the regulation, it's an important difference. A phase out is exactly what it sounds. That is that there is a red line, a line in the sand, a date as of which manufacturers of refrigerants like Chemours can no longer make a particular refrigerant. And when I say manufacturer, that also covers import. So for instance, a Freon 22, R22, is phased out as of December 31st, 2019. So after that date, we cannot make another pound of that. We cannot import, and nobody else can either. So that is a hard stop. Phase down is the language that's being used in some of the newer regulations, and there the goal is to, there's some baseline that's going to be set, and then the industry is going to be forced to reduce usage or reduce the climate impact of HFCs is how it's written today, and so it's a phase down. It's not a hard line on any particular compound is in or out. It's overall the whole basket has to go down. So you will have choices. For instance, you can continue to use R507 even in a phase down, but the drawback going to be the GWP of that is so high that it's probably going to have a cost associated with using that high GWP that a lot of people are going to want to avoid. Another way of saying it is the industry is going to move probably towards a GWP-weighted pricing on these things. So if you really want a high GWP compound, you can get it, but you're going to have to pay for it. And then that's kind of what we've seen in Europe, where the regulations are a little ahead of us, is that price escalation on higher GWP compounds. So phase out is a hard stop. Phase down means there's going to be pressure to move away from it, but it may still be available, and you'll have some trade-offs you'll be able to make.
Got it. Okay. Just a couple more, and then we'll end early just because we did cover a lot. But this is a technical one. I've heard there are some refrigerants that can be used in flooded chillers without changing the evaporator. Can you comment on this?
Right. So going back to flooded systems, probably R22 or 507. In general, you need to have a pure component refrigerant or an azeotrope to work in there. In general, the understanding, the wisdom has been that blends of refrigerants don't work in those systems. And there's been I would say some sporadic information out there claiming that can be done. I don't think that it's solid at this point. I think there's still testing and work going on. We're certainly looking at it. If you could do it, it would kind of be the holy grail. But to do it successfully, and you really have to understand how that's going to impact, and would your performance suffer in terms of capacity, that is in BTUs per hour, and the ability to do the chilling job, or would it hurt your energy efficiency so bad that you wouldn't want to do it? I would encourage anyone who is looking or thinking about that to do your research, because you really want to make a sound engineering decision here. And that includes looking at everything, including, some of the, I would say, the products that have been put forward to try and do that have, for instance, very high GWP. So you might be able to make it work, but is it going to just cause you more problems down the road from a regulatory standpoint, or when some of these other sustainability pressures come on? So I would say stay tuned. We're constantly, we have a lot of researchers, a lot of scientists and engineers looking at all aspects of this, really trying to take out the cost and get people to good, long-term, sustainable solutions that perform well and work for the long term. So, yeah, do your research.
All right, just a couple more. This one came in. Are industry manufacturers providing valves specific to or for XP40?
Yes, all the major, I would say, component manufacturers, starting with compressors, but valves, TXVs, leak detectors, gates, pressure gauges, all that. The industry is supporting very well XP40 and XP10. So yeah, all that should be available with part numbers from all the major component manufacturers in the HVACR industry.
All right, just one last one from the audience. Can you tell us what the power used by equipment to BTUs out ratio is? That might be a little bit specific to their.
Yeah. Well, that's typically a specification of a system, which is all the mechanicals as well as the refrigerant, and it's usually specified in terms of a EER, energy efficiency ratio, or the COP, or coefficient of performance. But that's really a spec of a particular system. So I think that would have to be on a one-to-one kind of answer.
Okay, cool. And so from that, just to finish it up then, for those one-to-one answers, your suggestion again is to reach out directly to you or to go to optforbetter.com/NHL, right?
Correct.
All right. For those folks, I think we covered all of it. There was another one or two questions that I can also always follow up separately, or the Chemours team can. But thanks for your time, everybody. We hope this was really useful. And again, reach out to us for anything. We are happy to share this information with you and to do a deep dive on your needs. We're trying to make, the NHL is really taking an interest in this. We're working with rink operators, rink associations, and everyone in this industry to understand what the needs are and to see how we can help out, provide and share best practices and insights to address industry concerns. All right. Thanks, everybody. Take care.
Thanks, Omar.
And thanks, Chuck.